Hello and welcome to After Dark Online. This week we are celebrating National Archaeology Week, so it's only fitting that this month's installment of After Dark Online is on the subject of archaeology. My name's Marc Cheesman. I'm a PhD candidate at the UQ, at the University of Queensland, also known as UQ, here in Brisbane, in archaeology. So I'll be doing a presentation called The Biggest Secret in Archaeology and How We Know What We Know. So it's not a small story. But before I begin, I'd like to just acknowledge the traditional owners of country throughout Australia and their continuing connections to land, waters and community, and pay my respects to Aboriginal and Torres Strait Islander cultures and to elders past, present and emerging. So this is just a really brief overview of sort of what I'll be talking about. So it's basically just broken into three sections. Archaeology, sort of what is it and what are the problems that we sort of have when we're trying to do this, and then methods and theory. And before you freak out about the theory, I've included lots of I won't even mention that. It's going to be a fun ride. So archaeology. I've got two definitions here, and they're sort of from different eras in terms of how archaeology has been performed in the last sort of 50 years, but ignoring the history of archaeology, let's just have a look at the definitions. So from the early 2000s, archaeology is a social science in the sense that it tries to explain what has happened to specific groups of human beings in the past. And so from the early 70s, archaeology is the discipline with the theory and practice for the recovery of unobservable hominid behavior patterns from indirect traces in bad samples. So you can see there that I've highlighted indirect traces in bad samples because that's kind of what I'll be focusing on, is the problems within archaeology. So the purpose, sort of combining those definitions together, the purpose kind of comes out as understand past human lives through material remains. And so what we mean by that is essentially the rubbish that people throw away. Most of the time that's what archaeology is looking at. So the problems that we encounter, first of all, there's no direct observation, so we can't ask the individuals that we're investigating because they're not around. Most of them are well and truly gone. The nature of the evidence is fragmentary and incomplete, so we don't really know how much is missing, we don't know how much was there in the first place, how much has either been disturbed or is actually just degraded away. And because of this, and for many other reasons, inferences and interpretations of the evidence are necessary. There's no direct evidence for usually the questions that we're asking. The evidence is usually indirect. And often these interpretations can be quite subjective, which is one of the problems that we'll be talking about later. And because I don't have time, I'll just point out that on the image on the right here, which is just a representation of a stratigraphic profile, which I'll explain soon, you can see on the right-hand side at the bottom that I've crossed out stone arrow point and put elf shot. So if you look in my references at the end of this presentation, you'll have an interesting read. So given the problems that we have with the indirect evidence and fragmentary evidence, how do we even answer the questions that we're putting out there? How do we provide a meaningful and evidence-based interpretation of what's going on in the archaeological record? So generally that would begin with constructing, so no, not reconstructing, a material culture history. So this has been going on for a long time in some regions, but in other regions not so long. In other words, basically just get out into the field and look at what's in the ground. Of course it's not that straightforward, there's a lot of methods and it's very controlled excavation, but I'll get into that in a minute. But basically we're looking at the archaeological record, which is essentially, as I mentioned before, the rubbish that's in the ground. Which we also refer to as material culture, just to make it more confusing. So based on that process, knowledge is generated about the past and explanations are then tested against the archaeological evidence. We'll try and explain something. Does this explanation make sense when we look at the evidence? And the key steps for this process would be locate, so like find the site, so where is the site actually located, excavate the site, analyze the material that's come out of the ground, and then put all of this together, so synthesize some kind of interpretation of what's going on. So Dr. Serena Love, who'll be presenting after me, will be talking about the first step. I'll sort of be talking about the last step. So again, just to make it nice and confusing. So what does construct a culture history, what does construct a material culture history mean? At the individual site level, so around the corner here in Brisbane, there are sites that are related to the Cross River Rail, tunnel creation, or sort of the train station creation. So when we first arrive at the site, prior to arriving, I guess we do historical investigations, but ignoring that for the moment, when we arrive at the site, we would do excavations, so we'd actually just start looking at the ground and taking off layers of the ground. But throughout this process, probably the most important thing for this part is careful and precise recording of the relationships of where everything actually is that we find. So that would be recording with photography and also drawing and measurements and sort of recording where everything is. And then the bottom picture on the left, taking all of this back to the lab and, if possible, identifying everything, but that's usually not the case. It's usually much less than 100% identification. And then when you put that together, you can then produce what's labeled here as a stratigraphic profile, but we could also call it a material culture history. So each stratum that you can see that's horizontal is a deposition which builds up through time. And I'll sort of explain this in a later slide. But these artifacts that occur in distinct strata, so one individual stratum and plural is strata, the artifacts that occur are grouped together into temporal and or spatial units. So basically it just means that this unit was deposited and then at some time later the unit above it was deposited, and all of these objects in here are related in some sense. So what does that mean at a larger scale? Well, we can put the information that comes out of each individual site together, and depending on the research question that we have, we can come up with some kind of understanding of what's happening at a much larger scale, whether that's just a larger region across Brisbane City, for example, or across the entire continent, or in this case, across most of the planet. So I don't have time to go into this, but again, I've got some references for further reading if you're interested. And so I've so far sort of spoken about the methods. So what do we do when we're out there and in the lab? So we excavate, we record everything, which again I should probably reiterate is the most important part. And then we analyze what we've found, we bring it back to the lab, analyze it, and produce some kind of interpretation of what's going on. And how do we do that in terms of the theoretical underpinnings that are required? Actually, I might just rephrase that. How do we have confidence in the interpretations that we produce? So the knowledge for this comes from two places. So one, the first place would be inside, so inside the archaeological record. The second place would be outside, so I'll get to that in a second. So the first part of knowledge from the inside is stratigraphy, which is what I was talking about just before. So objects found in association, so within an individual stratum, are associated in time. It's a little bit more complicated than that, but we'll just ignore that for the moment. And as you can see here, the lowest one is the oldest, and then they're subsequently deposited, and so we have some time depth there. So comparing earlier and later assemblages within an individual site can provide some kind of information on what technology is present, possibly trade, food resources that are available, that kind of thing. So in terms of what was happening here at Cross River Rail, we did find a layer associated with either the 1890 or the 1893 flood. So the research project that I'm doing, which again won't get into because of time constraints, but I will be looking at everything underneath the 1890 or 1893 flood layer, just to give you an idea of what that means in practice. So everything above that is outside the scope of my research project. Everything below that is the right sort of, it's within the right period, the right time period for me to be looking. Okay, so knowledge from inside, part two. So this is archaeology's biggest secret. And so I probably should have, but I didn't really go about, requesting access of whether or not I could talk about this. And I just thought, well, it's a live stream, so what's the worst that can happen? Okay, that's embarrassing. I guess they monitored my emails. Okay, well, we'll move on from there, and I'll see what I can do about bringing some of that in later. So knowledge from the inside, part three. Just forget that happened. That's not part of the script. So we can also look at typology. So what I've got here is just an image which shows you the historical development of Mickey Mouse. It's a bit of fun. Below that, there's various forms of, I think it's a gin bottle, but since ceramics and glassware are not my sort of research area. I actually have no idea, so don't quote me on that. But the study of form and physical characteristics of objects and how they change through time based on artifacts found in the archaeological record, this can actually allow us to group objects together and produce some kind of date estimate for when the deposit was laid down. So as I mentioned before, we found a layer that was relating to the 1890 or the 1893 flood. So the stuff that was below that, through this process, was roughly dated to earlier than 1890, and the stuff above that, through again this process, looking at the bottles and the ceramics and these kinds of things, was dated to after that. Okay, so knowledge from the outside. So what I've just spoken about was all things that we directly relate to the archaeological record. So this is the information that's coming out of the ground. So the other side of this is the information that we get from outside of the archaeological record, is what I'm referring to here. So the first part, I'm just referring to generally just science. So we do pull a lot of information from other scientific disciplines. That's what I'm trying to convey with this Indiana Jones meme. So for example, the sources of knowledge related to archaeology that we would refer to would be ethnography, which comes from anthropology, ethnoarchaeology, so observation of people to explain specific archaeological phenomena. So whether that's how do people create a specific kind of tool, or sort of how do they process their food, these kinds of things, and what's the waste deposits that are produced through that process, and do they match up with what's in the archaeological record. And then experimental archaeology, which is quite similar, which is if we recreate a specific kind of tool or specific process as an experiment, what is the waste that's produced through that, and what is the outcome, and so how closely does that match with the archaeological record. So some other sources of knowledge, so basically just other scientific disciplines. So geology, so I've already spoken about stratigraphy, we just pinched that from geology, so thanks very much. Physics, so you might be familiar with carbon dating or C14 dating. Biology, anything we can get our hands on basically that's going to help us understand what's in this fragmentary archaeological record. So another part of the knowledge from outside is this horrendously named Uniformitarianism, which is not a fun word to say or spell, just putting that out there. So this is another one that comes from geology. I won't get into what it means in geology, but it's fairly similar to how we use it in archaeology. The present is the key to the past. So basically what's on the slide here, and I guess I should thank these two gentlemen from the 19th century who came up with this idea, but what's on the slide here is a series of axes, and so we can kind of recognize that they're axes because we're familiar with what an axe looks like and how to use them. Same goes for the shoes on the slide sort of in the center of the page. We know what a shoe looks like because we use them in our day-to-day life, so we can recognize them in the archaeological record. So this works for functions, so what are tools used for. This works for processes, so how do sites form? We can sort of observe that in the present world and sort of infer that in the past it's the same process. Same with making or processing things. We know how to sort of if we know how to create something today and it's a type of technology that's been in use for a long time, we can infer that the process was more or less the same in the past as well. Same with settlement systems. And so as a consequence of the way that we use this kind of interpretive leap, I suppose you could call it, specifically in archaeology, one of the consequences that I'll outline here is sort of produces a lot of problems, I suppose. So we create the past in terms of our understanding of what the archaeological record means based on our understanding of what people do in the modern and recorded world. So as a result, archaeological understanding is bound to the present and reflects our understanding of the world which we currently have. And this is prone to periodic shifts, sort of changes in how we understand the world. So again, don't really have time to go into this, but I've got some further readings in the references section. This interpretive fluidity allows manipulation for political and/or financial gain, among other things. So we have to maintain a critical eye on interpretive claims and how they're justified. So basically, is there evidence of whatever the claim might happen to be, and is the evidence supportive? So archaeology is, as a result of this, archaeology has increasingly moved towards a more explicitly defined and transparent method of making and evaluating claims. basically we're just trying to be more open about what the process is that we go through to arrive at an interpretation, so that we can lay out the methods that we've used, and other people can then have a look at these methods and say that actually doesn't make sense, or that seems really good. And so the way that we do that, the way that we sort of try to be more open and explicit is with clear research questions and methods which match the research question, peer review, public presentations like this, and academic conferences where people can tear each other's work to shreds. And sort of what I've got on the slide here is the one on the top left is a really good example of somebody taking one archaeological assemblage and applying all of these different kinds of interpretations to it, but it's literally the same assemblage, they're interpreting it in various ways. So that's a really good book if you're interested in archaeological theory. So I've probably narrowed down the interested parties quite a lot. And the one on the bottom there is a really important paper if you're interested in how archaeological interpretations can go very wrong, and not just in the sort of, you know, having fun with ancient aliens kind of way. So I guess I can try and sneak in the biggest secret in archaeology. What is that? Okay, so the biggest secret, as it turns out, is context. Might sound like a reach, and let me define it first in archaeological terms. So it's a relational quality. So the position of an archaeological, there's too much jargon in this sentence, but basically where something was found in the archaeological record, so where it was found in the ground and how it relates to everything else. So this is why recording and very meticulous slow excavation is very important. So likely this is the most important concept in archaeology, and it's the main reason why, at least from an archaeological perspective, why looting is basically just very bad. Because once something is removed from its archaeological context, its scientific and archaeological value plummets. It basically just doesn't mean anything. If somebody hands me a glass bottle and says, where is, you know, what does this mean? When is it from? I mean, maybe I'd be able to date it, although again, I don't know anything about bottles, but I don't know where it's come from. I don't know what the context is. So it just basically means nothing, unfortunately. But bottle collectors would probably enjoy it. So it more or less becomes an art object once it's removed from its archaeological context. Yeah, okay, and so I hope I've captured somebody's interest in archaeological theory, because it is actually probably much more interesting than I've made it sound. There's some very important papers in there which I would encourage you to go and have a look. And I'd like to acknowledge this many people, and also Professor Andy Fairbairn for allowing me to pinch some stuff from some of his Intro to Archaeology course. And thanks for listening. I'd now like to welcome Everick Foundation's Principal Research Archaeologist, Dr. Serena Love, to talk about locating archaeological sites and how to know where to dig. So thanks for listening.
Hello, thanks, Mark. I'm going to talk about how we locate archaeological sites. So archaeologists are always asked, how do you know where to dig? And it might seem like guesswork, but there are several influences behind our decisions. It begins with what we know as a desktop study. So before we even put a hole in the ground, we have a look at all the available information that is related to the area of interest from our desk. And for this desktop study, we started, so actually this study that I'm going to use as an example is using the GoPrint site as part of the Cross River Rail excavations in Woolloongabba. And so before we started this project, which was done by Niche Environment and Heritage Consultancy Company, they had a look at everything that they already knew about it. So for the desktop study, they started with the Queen State Archives and the Brisbane City Council Archives. And then I'm going to use this as an example of the excavation that happened in 2019 at Woolloongabba on the south side of the Brisbane River. So this was known as the GoPrint site, and it was excavated as part of the Cross River Rail project. So locating archaeological sites. So first of all, we do the desktop study, which I'll get into, which talks about which we use, the sources that we use, the historical sources, archival material, and then we do a predictive analysis using other kinds of archaeological information that we know from around the area, and about the soil types and topography and what we know about flooding and erosion, and then we can kind of predict what's still going to be there and what would have been damaged by previous activities. And then I'm going to talk about some really cool technology that we do, from like aerial surveys, LiDAR, geophysics, and then some satellite remote sensing. So the first question that we ask in a desktop study is, what do we already know about Woolloongabba? And we start by going through the archives using old maps, drawings, and photographs to tell us what used to be here about 150 years ago. So this map is from 1863, and you can see that most of the people in Brisbane at this time were living in what is now the CBD. South Brisbane was only starting to grow by the mid-1860s, and the area around Woolloongabba was once called 1 Mile Swamp, named after the creek line and chain of waterholes that ran through the area. This area was a wetland, and no one was living here at the time. And this map from 1887 shows a big change from the previous map just 20 years later. The area is no longer a wetland, even though it is still called 1 Mile Swamp. The streets are in houses. The Woolloongabba railway line was built, and now there's a cricket line east of Main Street. And then in 1895, the Brisbane Cricket Ground was developed, and the first match was played at the Gabba in December 1896. The second part of a desktop study is to look at the historic aerial photographs to understand the original land use of the Go Print site. So we can learn a lot using historic aerial photographs, such as what buildings used to be on the land and which ones have since been demolished. We can also learn if anything would be buried in that location, such as an old brick drain and some pipes and an old tram track. So this picture was taken from 1842 and shows the area around Woolloongabba. And we can see just how densely it's been built up. And we can see how many people are living around the area, and all the roads and the railway and the large buildings in the area. We can use this historic photograph from a series of these to see how the area changed through time. And this image, I might add, is actually available online for free on a Queensland website sponsored by the government called Q Imagery. And you can go and grab any of these. So the third tool that archaeologists use to know where to dig is about similar excavations in the area. So we take in the historical research and combine it with the results of similar archaeological excavations to predict what we might find in the area of interest. We know that there used to be shops here in the 1890s, so we might find the remains of these shops. We might also find old buildings or tram tracks, as we know that they were here and that there was a rail yard and some timber yards nearby as well as a fire station. And some of these early buildings had cellars and brick drains, like this picture here, which you can also find during the excavations. And then in studying these previous works, you put it all together. And the archaeology team at Niche put this together. This was the zone of archaeological potential. And we can use this information to identify these different areas where we think things might still be intact. And everything there is mapped in pink. And once this desktop study is done, then we can visit the site and see what it looks like today. Now, and then we can go on what we call ground truth, and that's where we actually go and look at it on the ground to see what it would look like today, and then you begin your excavations. So that's how we know where to dig using just from a desktop study. Now I'm going to move into some of the more technical side of things and using some new high-tech technologies that are usually been developed for other purposes, but we've adopted for archaeology so that we can get a better sense of seeing things from like the air, for example. So this, a lot of people are starting to use aerial surveys, especially now with drone work, but we can also do it with helicopters. And so in this example was a helicopter survey I did a couple of years ago. And the reason for doing it was a really big area, and it was quite inaccessible by foot, and it would have been very dangerous. And so what would have taken me days and days to do on foot and in very treacherous ground, I could actually do in 2 hours with a helicopter. So we flew up and down basically a cliff face. We were looking for anything with caves or possibly even rock art, and we had some high definition camera gear with us to photograph these. And then once we isolated down where these were, then we can go and ground truth it and go and look for them on the ground. But one of the other things that we can do is do drone work. And this would be really good for something a little bit smaller. So for example, we've got a stone circle that's in central Queensland, and when we've got fish traps. And so some of these, you just can't see them when you're on the ground. You could be standing right on it and it's just completely invisible. But if you see it from the air, the shape of it starts to take form. And so aerial surveys, including this drone work, gets to be a lot more popular now. And the application for cultural heritage management and for archaeological research is getting really popular in lots of lateral applications. But one of the other ones is LiDAR. And this is a method for measuring distances by illuminating the target with a laser and measuring the time of the reflection of the light takes to return to the sensor. So the differences the laser can return, the times and the wavelengths, can be used to make a 3D representation of the target. And this has terrestrial, airborne, and mobile applications. So what's really fantastic about this, you can see both of these images side by side, is with the current vegetation, and when you look at it from the air, you just can't see it at all. But when you put the LiDAR on it, it just stands out, and then you know exactly where it is. And I've seen the same kinds of things done in Central America, where you've got major brick structures that have been completely absorbed by the jungles, but with some LiDAR mounted on aerial, either on drones or on helicopters, they just sing out, and then you can find out where they are, and then you can go and investigate them on the ground. One of the other methods is geophysics. And there's two methods here. One is magnetometer, apologies, that's misspelled, and then the other one's ground penetrating radar. So this is magnetometer works by sensing the tiny differences in the Earth's magnetic field, which is much larger than the tiny signals produced by archaeological features. But the instruments used are being able to ignore the background field and are very good at picking up relatively weak archaeology. So this is a photograph of Dr. Kelsey Lowe, who is an expert in geophysics, and this is her working on Stradbroke Island. And we, a couple of years ago with University of Queensland, went out there looking for an old excavation from the 1980s. And we knew that they had metal, what we call shoring, inside the pit. When they abandoned the pit and filled it in, they left the metal, the sheets of metal up. And so with this magnetometer, it absolutely sung out, and we could find it dead easy. And then here's another example of magnetometer. So it measures the patterns of magnetism in the soil by using this instrument. And so you walk across the ground in a grid pattern, and on your body you can't have any metal. So you have to make sure all your clothes doesn't have zippers and none of the buttons, no metal on your body whatsoever, because that's how sensitive this instrument is. And you walk along in the survey area in an organized grid, and the result of the data is used to produce a map of the terrain and up to 2 meters below the surface. So here you just see a normal plowed field, but with a magnetometer data you can actually find that you've got Roman features inside of it. Another one is ground penetrating radar. This technology emits bursts of radar that penetrate the ground. So ground penetrating radar is extremely useful for archaeologists because it's another type of non-invasive technology that can map out the differences in soil composition to identify features without disturbing the surface at all. So the basic operating principles is grounded on the fact that different types of materials, archaeological features, but also bedrock, and this is actually of a shell midden point lookout on Stradbroke Island. And they all have a different density and a different signature. So they show up in these different patterns. They have distinct physical and chemical properties that produce quantitative differences in energy transmission and the reflection measured by the radar. So again, this is a little device. There it is, and the actual radar is at the bottom. And then the monitor is at the top, and you just push it across the ground in a set pattern. And these are in the little image in blue that's got all the different colors in it. That's what's reflecting back. And then we were able to locate a shell midden for the Quandamooka people on Stradbroke Island. But there's some other great technology out there about space satellite remote sensing. And so this is using satellite imagery from satellites. And so when we're looking at new archaeological sites, there's a pioneer in this method by the name, an American archaeologist by the name of Sarah Parcak. And she gets the satellite imagery from about 65 meters by 65 meters, and she applies these filters to highlight the different proportions of electromagnetic spectrum. So she starts playing with the different light spectrums to look at the different densities. And if you compare these two images, what you can see, especially on the right, is that you've got a whole series of tombs and structures that you can't see just from a normal imagery. So the architectural structures that are buried underground can stunt the growth of basically the plants that are above it, creating a bit of a dead zone. So it might be invisible to the naked eye, but detectable in a shortwave infrared images. So the shape of these underground, so these features are actually not on the surface at all. They're below the sand by about a couple of meters. And so in places like Egypt, where the vegetation is scarce, satellite imagery can help the archaeologists distinguish between natural and man-made features, like the mud bricks that are used to make these tombs. So I'm going to end there and say these are just some of the ways in which archaeologists and how we know how to dig. Thank you.